So when that charge leaves the capacitor, runs through the light bulb, we get the capacitor discharges through the light bulb, we get a bright flash of light that's just temporary, and then all the charge is dissipated, and the circuit gets opened again. We can close, all these guys are gone, and then we have to close this one again and let it recharge. Have you ever had a camera that you have to wait for the flash to recharge? Or especially one of those disposable cameras? Are y'all too young to use disposable cameras? Anyway, if it had a flash, you had to like press the button to charge the flash, to charge the capacitor on the flash. And if you've got a fancy camera with a speed light on it, it still has to charge a capacitor, or it may have more than one in there, so you can take lots of pictures at once and use your flash. But it still will have a time where it's not ready. All right, and light is a form of what? Energy. Okay, and when I multiply coulombs and joules per coulomb, I get the unit for energy. So it looks like maybe the area under the curve would be the energy stored in our capacitor. Does that seem possible? So that's the energy stored. So we like to use U for stored energy, and if you want to put a little C beside it for it to represent a capacitor, we can do that. And how can I find the area under this triangle? If this is our voltage V and this is at some charge Q, 1/2 VQ, usually you'll see it as Q times V because it's like in alphabetical order or something. Now wait a minute, what does Q also equal? CV. Oh, so it would be really handy for us to make a substitution. So 1/2 CV times V, so CV squared. Now that's my favorite version of this equation because what does it look like? 1/2 something something squared. 1/2 MV squared. 1/2 KX squared. Oh, do you see the trend? 1/2 constant value. All right, once we put a capacitor into a circuit, we can't change its area. That takes taking it out of the capacitor and redefining it, okay? So think of capacitance as being a constant, that slope there. But we can change the voltage. Put a different battery in the circuit. So 1/2 mass times velocity squared. Usually in our problems, we don't have an object that's changing mass as it's moving. I mean, like a truck leaking or something, you know, we don't have to do that stuff. But but we had our mass that was constant times our velocity that could be different. 1/2 KX squared. 1/2 the spring constant times your variable squared. So that's why I like the 1/2 CV squared, because it looks like the other energy equations. It looks like the form of an energy equation. Like they could be cousins, symbols. All from the family energy. Whatever. Okay, so let's put a box around that guy. I think the top one is the one you get on the AP exam, and the bottom one is one you have to like come up with by substituting that guy in there. But that's your stored energy.